total product, marginal product, average product, total cost, total fixed cost, total variable cost, average fixed cost, average variable cost, marginal cost. That's a lot of graphs. Truthfully, we don't need to keep carrying around all of these diagrams as long as all of the information from one can be found in another. Let me show you what I mean. Let's compare our old average product, marginal product diagram with the average cost, marginal cost diagram. What do you notice? The range of increasing average product or increasing productivity is reflected in the cost diagram by decreasing per unit costs. The more productive your resources are, the cheaper it is to produce a unit of your product. Now, what happens when there's declining average product or decreasing productivity? This is reflected in the cost diagram by increasing per unit costs. As your resources become less productive, the more expensive it is per unit to produce your product. In the end, because we can see all the productivity information reflected in the costs, we no longer need to use the product curves. This leaves us with the average cost diagram versus the total cost diagram. Let's take a look. Can I get all of the cost information from this graph? Okay, let's start with the obvious. It's a total cost diagram, so we should be able to find the total cost. Say the company wants to know just how much it will cost overall to produce 7 units, or 700 units, or 7,000 units of output. This one I can just read straight off the graph. At 7 units, the total cost is $63. Now suppose that you'd like to know, out of that $63, how many dollars are going to overhead costs that must be paid regardless of the output, that's your fixed cost, and how many dollars go to pay for variable resources like labor or raw material? Well, this breakdown isn't hard to figure out if you remember one thing. Fixed costs are the same no matter how much output you produce, even if you produce no output at all. But at no output, I don't need to pay for any of the variable resources, meaning that at 0 output, all costs are fixed costs. So in this case, my total fixed costs are $21. This also tells me that to produce 7 units of output, $21 of the $63 in total costs represent overhead or fixed costs. Of course, this must mean that the other $42 pays for variable resources like labor and materials. Knowing that the total cost of producing 7 units of output is $63, this tells me that the cost of a single unit, or average total cost, is $63 divided by 7, or $9. The fixed part of a single unit, or my average fixed cost, is $21 divided by 7, or $3. It follows that the variable part of the cost for a single unit must be $6. Either take the total variable cost of 42 and divide it by the 7 units that you're producing, or subtract the average fixed cost of $3 from the entire cost of a unit, $9. This leaves only marginal cost. Remember, marginal cost is just the extra dollars I add to my cost by producing 1 more unit of output. In this case, because 6 units cost $60 and 7 units cost $63, the marginal cost of the 7th unit is $3. It costs $3 more to produce that 7th unit. It looks like I can get all the cost information from this diagram. Now, what about the average cost diagram? Can I get total cost, total fixed cost, total variable cost, and all the rest of them? Let's take the easy ones first. I can read average total cost, $9, average variable cost, $6, and marginal cost, $3, straight from the diagram. What about the rest? Well, average fixed cost isn't too difficult. On average, a single unit costs $9, $6 of which is variable, meaning the other $3 must be the average fixed cost component. Now for the total costs. If 1 unit costs $9, how much do 7 units cost? $9 per unit times 7 units is $63. The variable piece per unit is $6, so the variable cost of all 7 units must be $42. Therefore, the remaining $21 represents fixed costs. Conclusion? We can get all of the cost information from either of the diagrams. Which one will we continue to use? We're going to continue by using the average cost curves diagram. Students often groan when I tell them this, but there is a good reason. Our next step in looking at business decisions that are based on maximizing profit is to bring in information about the product price so that we can compare that to the cost. Since goods are priced per unit, we need to be able to clearly see the cost per unit. Let me show you. If I go back to the average cost diagram that we just looked at, but now I put in a price tag, you should be able to tell me instantly if this producer is making money or losing money. Remembering that the average total cost or cost per unit is $9, what happens if the product price is $10? This producer makes $1 on every unit above and beyond the cost per unit, so there's $7 total of profit. Now, what if price is $8? The producer is not bringing in enough per unit to cover the costs. In fact, the firm loses $1 on each unit, so there's a $7 loss. How will I know if the producer is reaching the objective of maximizing his or her profit? That is a problem for another day. Next time, market structures.